So as you can see, uh, fermentation process is very important topic in various competitive exams also, and also in perspective of industrial microbiology. So we will discuss today about fermentation process. Various fermentation process are very important. Let me show you. This is the fermentation system. So fermentation system means you have a chemical reaction. You will do a chemical reactions actually, but here there is no catalyst. Here you will use an enzyme. So you will have a reactant, you will have a product, but the catalyst will be acted by some enzyme which will be secreted by a bacteria. So you will give a bacteria, you will have a reactant, you will get a product. That's all the fermentations. So fermentation systems can be produced by three systems: batch culture, fed batch culture, continuous culture. So this all the process, the main basic principle is to increase some steps in bacterial growth. We will discuss in progressive. So bacterial growth pattern we have to know to let us understand the whole idea of fermentation system. So bacterial growth pattern for the microbes is very important. Microbes means here we are saying, let me show, here we are saying for actually bacteria and fungi. So here we are saying for bacteria and fungi, as you can see here, bacteria and fungi, that's what we are saying. Okay, so growth means actually in bacterial system the increase in number of cell of the bacteria or increase in biomass. Okay, so chunk of bacteria cell will be called actually as biomass. Okay, so now we have to understand actually the bacterial cell growth. So bacteria have a pattern of growing. So in this video we will discuss a bacterial cell growth curve. Bacteria has a typical curve to grow. It follow every time. So we will discuss in this video bacterial growth curve, and in progressive video we will discuss the different fermentation system like batch culture, continuous culture, fed batch culture. So the bacterial growth curve actually looks like this. Bacterial growth curve looks like this, as you can see here. Okay, this is the typical bacterial growth curve. So here you can see the Lac phase. This is the Lac phase. Lac phase. In the Lac phase, a bacteria actually doesn't grow that much. The number of cell for the bacteria does not increase that much. But what happens? Bacteria try to adopt the atmosphere surrounded by the bacteria. So as you can see here, this is actually called the acclimatization phase. Actually no growth of the bacteria, but actually bacteria cells search for new nutrients in the new atmosphere and modify its machinery to use the new nutrients. So in this phase, Lac phase is the primary phase of the bacterial cell culture, bacterial cell growth curve. In this phase, no bacterial cell increment, number of cell increment or biomass doesn't increase that much. Not that much, at least no amount, it doesn't increase. So in this phase, Lac phase or acclimatization phase or halt phase, in this phase only bacteria try to modify its machinery so that it can adapt to use the new nutrients. Next step is log phase. This log phase, as you can understand, the name suggests that log phase is exponential growth of the bacterial cell, and you can see also in the graph a sharp growth of the number of cells or number of biomass. So you can understand from the figure that y-axis is actually increase in biomass or increase in number of cells, and the x-axis is actually generation time, on time, how much biomass is increased, how much number of cell is increased is we are plotting here in this graph. So this is called log phase. In log phase, exponential growth of bacterial cell happens and medium becomes very much viscous. So there are 2 points: exponential growth of bacterial cell, very high increase of the number of cell of bacteria happens in this phase, and next is medium becomes viscous. So growth profile actually happens 2 to 4, 4 to 6, 6 to 8 to 16, like this. That's why we are calling it as a log phase. It happens in exponentially increase. So in this phase, you cannot measure the number of increment of the cells by some other technique. You have only one technique people use normally, that is measurement of absorbance, or OD measurement, optical density. Optical density is how much light is absorbed by the solution. So that is denoted by optical density. So but typical optical density for the log phase of the bacterial culture medium is happens to 0.5 to 0.6. So normally what happens, we try to make some protein, try to express some protein in the bacteria. So in bacterial cell culture, we try to we allow the bacteria to grow. So when we can see that bacteria solution is showing OD, optical density 0.05 to 0.06, then we can understand that yeah, we are in the current, we are in the right directions. That is log phase is happening in that time. Okay, now so log phase, the second phase of the bacterial cell growth curve. In this phase, exponential growth of the bacterial cell happens and medium becomes viscous. Okay. So next is the late log phase. So in bacterial cell growth curve, log phase is very important for industrial microbiologists, because in this phase only various primary metabolite going to produce bacteria. So this is the target phase for the bacterial cell culture for the industrialist. Next is the stationary phase, where the limitations of the nutrient actually stops the growth of the bacteria. So actually what happens in log phase, the bacteria are increasing in huge amounts. So all the nutrient present in the medium is going to be finished. So stationary phase, when it goes to stationary phase, the bacteria cells, there is no nutrient left. That's why they feel lack of nutrients. That's why the limitations of nutrient stops the bacterial cell growth. Hence in this phase, to defense by some defense mechanism by the bacteria, by some defense mechanism, bacteria actually produce some secondary metabolite, the byproducts. So industrialists whose main requirement are actually secondary metabolite, like ampicillin, various drug secondary metabolite is very important topic in research field. Then their target is actually stationary phase. So in stationary phase, secondary metabolite forms. Stationary phase, stationary phase is the third phase of the bacterial cell growth curve. Here not that much growing happens because of limitations of the nutrient in the medium. So bacterial growth stops and byproducts form in huge amount. That's called secondary metabolite. And the last phase is death phase. Here actually no nutrient remains. Toxic byproducts formed. Toxic byproducts actually helps to kill the bacteria cell whatever already produced. So toxic byproduct plus actually no nutrients, that's a limited nutrient, bacteria starts to die. In this phase bacteria starts to die. So this phase we don't want. Lac phase also we don't want. As an industrialist, we only want log phase and some extent stationary phase. So that's all about bacterial cell culture. In the latter video we will discuss about the various fermentation process. So this is very important for bacterial cell culture. So here you have to remember one thing. There's the generation time. So in the log phase, actually one bacteria is going to two bacteria, 2 to 4, 1 2 3 4 like this. So here a term very important for exam purpose, that is the generation time. So what happens here? Sorry, my pen is not working. I don't know why. Okay, so this is generation time. That is actually T by del N. Del N means, let's say you have N1 number of bacteria. You have one bacteria and it grows to 6 bacteria. So del N will be N2 minus N1. That is 6 minus 1. That is equal to 5. And T is the how much time is required to grow that amount of bacteria. So mu is equal to specific growth rate. That is number of cell division per cell per unit time. That is the specific growth rate. So G is an important parameter for the bacterial cell growth. G is actually T by log N2 by log N1. Log N2 by log N1. This is very important parameter you have to remember for exam purpose. Now, next is we will discuss about so in this exponential growth phase, actually cell division happens in exponential manner, and mu x dx dt. that is specific growth rate equal to mu, and cell dry weight. So mu x is calculated by mu x, that is faster kinetics, equal to dx by dt. Dx by dt is the number of bacterial increment, number of bacterial cell, how much bacterial cell has been increased in that time, and mu is the specific growth rate, and x is the number of cell dry weight. Cell dry weight means after drying the bacterial cell, what is the weight we can get. So in Lac phase, Lac phase, we have to something remember that Lac phase actually period where cell number is actually 0. No cell increment happens, but cell size can increase. Means biomass in number doesn't increase, the biomass size can increase. Lac phase result from different factors. Cells are placed in a fresh medium. That's why intracellular concentration of the cofactor amino acid varies and decreases. So they have to be synthesized or transported inside the cell before division to occur. So as you can see here, let me check my pen. Yeah, so cell are placed in the fresh medium, intercellular concentration of the cofactors amino acid and varies and decreases. That's why they have to be synthesized or transported fast inside the bacterial cell so that cell division can occur. Next was the inoculation of the cells in different medium having carbon source enzyme in metabolism have to be transported from it have to be transported from the medium to inside the cell. That's why it needs time. That way Lac phase happens. Medium containing several carbon source can result in different Lac phase called dioxic growth. Means different carbon source are taken up by different bacteria. They are following different growth curve. Then it will be called as dioxic growth. So and this is the main curve. So this is very important for various for concept we will discuss in the next video. Feed batch and continuous fermentations. So if you like my video, if I can help you, then try to follow it, subscribe and share. Thank you for watching. Thank you for your time. That's all for today. We will discuss in the next video tomorrow, and bye bye. That's all.